Welcome to the largest particle physics laboratory in the world. Right now, you're standing inside CERN, the European Organisation for Nuclear Research.
For over 6 decades, the CERN has significantly contributed to scientific development and our understanding of the universe's origins. It is also the world's most advanced centre for particle physics experiments. Their research even helped resolve debates surrounding the existence of the Higgs boson, sometimes referred to as the God particle.
By studying the collisions, scientists have already made a major discovery, the Higgs boson. Some call it the God particle.
However, something unsettling occurred during the third run of their Large Hadron Collider, a primary technology used at CERN. What transpired during this third run, and what implications does it hold for CERN's experiments and the future of humanity? Join us as we discuss the most terrifying event in particle physics research, CERN and the Large Hadron Collider. CERN is the European Council for Nuclear Research. It was founded in 1954 with an initial goal of building blocks of atoms, but science has come a long way since then. Today, CERN investigates particle physics. This is done at a giant lab between France and Switzerland. It's a truly international team effort, with 23 member countries and the top physicists, engineers, and technicians from all over the world working together on machines that crash particles together at super high speeds. Here is the exciting research they work on. CERN activities are like tearing apart a toy to figure out what's inside. Still, the universe is the toy, and they are investigating the universe's tiniest building blocks. Scientists can learn about the essential pieces of matter and how they work together by studying these crashes. However, the CERN relies on a particular machine called the Large Hadron Collider, or LHC.
The world's most powerful particle accelerator. The Large Hadron Collider will reopen today after 3 years of being shut down for improvements.
The LHC is a fantastic feat of modern engineering, and its size will leave you speechless. LHC is like a giant circle that spans 27 kilometers long and is buried underground. Inside the machine, tiny particles called protons zoom around this track nearly as fast as light before they slam into each other. It may also be described as a racetrack for particles even smaller than atoms. But the LHC is just one piece of the puzzle. CERN has many particle accelerators and detectors, each with its particular task, but we will focus on the LHC today, which is the most important of these machines. The Large Hadron Collider, or LHC for short, is a record breaker in many ways. It's the most giant machine, a powerful particle smasher, and a complex experiment facility. The European Organisation for Nuclear Research built the LHC between 1998 and 2008. It required efforts and resources from several nations, even outside Europe.
France is hosting a meeting of ministers from 16 pro-nuclear European states. The meeting is aimed at coordinating the expansion of atomic power and urging the EU to recognize its role in meeting climate goals for 2050.
More than 10,000 scientists and engineers worldwide worked on it. When it started running experiments in 2010, the LHC was 4 times more powerful than any collider before. It could smash particles together with much more energy, allowing scientists to study the universe in a whole new way. Are you wondering why the scientific community buried kilometers-long machines underground between 2 European nations? Here is why. Scientists have a pretty good idea of the things that make up the world, called the Standard Model. But then this information needs to be completed. The LHC allows them to test this Standard Model to see if it works under super powerful conditions. LHC is like a giant experiment machine, helping scientists hunt for entirely new matters in the universe. Our knowledge of dark matter and energy still needs to be completed, and the LHC helps to investigate and ascertain these matters. Building and running the LHC is no small feat. It uses super advanced technology like special magnets and superconductors that push the limits of engineering and computers. This amazing technology can also help to develop new tools and stronger materials for medical practice. The LHC is a considerable team effort, with scientists from all over the world working together. This giant collaboration helps them share ideas and unlock the universe's biggest secrets. The technology behind the LHC helped create better machines for medical imaging. The efforts that went into building the LCH will leave you speechless. Construction and operation of the LHC. According to a 2015 physics history paper by Thomas Schörner-Sedenius, the idea for the LHC goes back to 1977. Sir John Adams, who used to be the director of CERN, thought it was cool to build a giant tunnel underground. This tunnel would hold a particle accelerator that could smash matters together with super high energy.
And finally, it is the big collision they claim will give us greater understanding of the Big Bang. And today, scientists searching for the ever-elusive God particle claimed a victory when their Large Hadron Collider produced the first record-breaking high-energy particle collision.
The project got the green light 20 years later, in 1997. According to CERN, the ring uses 9,300 magnets to steer bunches of charged particles in two opposite directions. This happens very quickly, 11,245 times every second. Eventually, the particles smash head-on. The LHC can create a mind-boggling 600 million crashes every second. These crashes release much energy. Sometimes they produce strange and never-before-seen super-heavy particles. The LHC is much more powerful than any other particle accelerator before it. It operates at energies over 6 times higher than the previous record holder, the Tevatron Collider, which is now shut down at Fermilab in the United States.
Scientists from around the world gathered at nearby Fermilab to celebrate the impact of the Tevatron. Attendees kicked off a day-long symposium with a close-up look at the historic particle accelerator.
We are about to reveal the cost of the project, which is mind-blowing. The Large Hadron Collider, LHC, cost $8 billion to build. The United States chipped over $500 million, precisely $531 million, while the Europeans and other international partners bore the remaining cost. The LHC started operating in September 2008, but at that time, it needed to run at full power. The particle collisions only happened at 1/millionth of the strength they were designed for. In 2018, the LHC shut down for improvements. It was restarted again in April 2022, more potent than ever before.
Below the surface of the Earth, the quest to explain the first moments of the universe is resuming. With the help of the newly upgraded Large Particle Collider, over the last 2 years, the machine's 4 major detectors have been fitted with new sensors.
Now, it can collide particles at double the rate and with much higher energy. The ultimate goal is to smash particles together with record-breaking force, reaching an energy level of 13.6 trillion electron volts. Here is an exciting catch. Before the giant atom smasher started working, some people thought it might destroy Earth, maybe by creating a super strong black hole that would suck everything in. But any scientists would tell you there's nothing to worry about. The LHC director, Robert Amar, even said that the machine is completely safe and that any ideas that it might be risky are just made-up stories. Of course, that doesn't mean the LHC couldn't be dangerous if someone messed with it. For example, if you stuck your hand in the beam, which concentrates the energy of a moving aircraft carrier into a tiny space, it would hurt you. The beam is so intense it would burn a hole right through your hand, and the radiation in the tunnel would kill you. For the past decade, the LHC has been smashing atoms together for its 2 biggest experiments, ATLAS and CMS. This has produced a huge amount of research, over 2,000 scientific papers on many important topics in particle physics. It has also made some scientific findings that will leave you speechless. Amazing discoveries of the LHC. The first impressive performance of the LHC occurred in 2010. It achieved its first ever particulate collision at a mind-blowing energy level of 3.5 GeV electron volts per beam.
This year we are ramping energy to 3.5 tera-electron-volts, and that's why we need to complete this commissioning and we have to reach this year full functionality of a new QPS system.
About 4 times the previous world record. In 2012, the LHC helped scientists finally solve a central scientific puzzle that had puzzled researchers for a long time. Here's the story. Back in 1964, 2 groups of scientists made similar findings. One group was led by Peter Higgs, Francois Englert, and Robert Brout. The other group had Gerald Guralnik, Carl Hagen, and Tom Kibble. They both published research suggesting there was a particle called the Higgs boson.
Now let's have more on the discovery of the strongest evidence yet for the existence of the so-called Higgs boson, the subatomic particle that is thought to give other particles substance or mass. The announcement was made by researchers at their centre near Geneva this morning.
However, other scientists haven't widely accepted their ideas for several years. Some researchers even ignored them altogether, while others vehemently disagreed. Fast forward to 2012. The LHC came along and helped scientists finally prove that the Higgs boson really does exist. This discovery was a breakthrough, and the Higgs boson sometimes gets nicknamed the God particle because of its importance in our understanding of the universe. Finding the Higgs boson was a perfect discovery for particle physics. The scientists who discovered this particle back in 1964 were given the Nobel Prize for their work in 2013. That's not all.
The Large Hadron Collider in Switzerland confirmed Professor Peter Higgs's theory of the boson, or particle, that gives mass to matter. It has always seemed likely that he would win this year's Nobel Prize for Physics.
Another shocking discovery of the LHC is tetraquarks. In 1964, two scientists tried to understand subatomic particles called hadrons, bounded by a strong force. Independently, they both came up with the idea that hadrons were made of smaller particles. George Zweig called these tiny parts aces, while Murray Gell-Mann named them quarks. Gell-Mann also suggested three types of quarks: up, down, and strange. Later on, scientists discovered three more quarks: charm, top, and bottom. In 2003, scientists in Japan stumbled upon a weird particle named X3872. It was built from a charm quark, its anti-charm, and at least two other quarks, which didn't fit the usual picture of how quarks combine. While conducting further investigations, they spotted another odd particle, Z4430, also seemingly made of four quarks. Since then, the LHC has found proof of more particles like these, disrupting scientific understanding of how quarks should stick together. These Z particles are short-lived, but they might have existed for a tiny fraction of a second after the Big Bang. That's not all. Scientists at the LHC made an exciting discovery when they switched things up in their experiments. Usually they smash protons together, but this time they slammed protons into lead nuclei. Instead of the usual random spray of subatomic particles after the impact, the particles seem to be moving together in a coordinated way. One explanation for this surprising finding is the creation of an unusual type of matter called quark-gluon plasma. This QGP would have flowed like a liquid and spit out the coordinated particles as it cooled down. Scientists at Brookhaven National Labs and the LHC have already made QGP. It's the densest matter you can find anywhere besides what's inside a black hole. QGP is formed by smashing super heavy particles like lead and gold ions together. If scientists can confirm that they made quark-gluon plasma by smashing protons and lead nuclei together, it would be a breakthrough. This is because QGP is thought to have filled the universe right after the Big Bang, and studying it here could help us better understand what the Earth looked like immediately after that period. But there's a bit of a puzzle. According to our current theories, the crash between a proton and a lead nucleus shouldn't have been strong enough to create QGP. This unexpected finding makes scientists rethink how much energy is needed to cook this matter. Even though the LHC has made astonishing discoveries, like finding the Higgs boson in 2012, the work is still ongoing. Scientists are now busy upgrading the LHC detector to prepare for a more robust version of the collider starting in 2029. Their next big goal is to study the Higgs boson in more detail and see exactly how it works. In the meantime, more shocking discoveries have been made in recent times that could spell doom for us all. Earth's magnetic field and other mysterious phenomenals at the LHC. At the beginning of the third run of the Large Hadron Collider, the Earth's magnetic field developed a tear that lasted about 14 hours. This tear allowed a bunch of solar wind particles from the Sun to reach Earth. The result? A big geomagnetic storm. This storm also caused beautiful auroras to light up the night sky. A co-rotating interaction region from the Sun caused the tear. These CIRs are giant clouds of gas and charged particles that form when different parts of the Sun's wind move at different speeds. They get flung towards Earth along with other things the Sun throws out, like coronal mass ejections. We sometimes see auroras when these CIRs collide with Earth's magnetic field. The good news is that scientists have now confirmed there's no need to panic. This kind of tear in Earth's magnetic field happens constantly and usually closes quickly. But another scary thing is that National Oceanic and Atmospheric Administration experts noticed this storm was extra strong. But Earth's magnetic field has protected us from these tears for a long time and will continue to do so. Even though Earth's magnetic field usually protects us from space storms, recent events show that tears can linger for hours and let more solar energy in than usual. Could this be caused by the activities of CERN and the atomic collider? In 2003, Harold Fryer used an analogy to explain this. He said the energy that gets through could be like a big show in the sky, causing problems for our technology or even messing up satellites, radios, and power systems. Luckily, this recent tear didn't cause radio blackouts or power outages. Instead, it brought terrific auroras to Canada and the United States. Scientists have also noticed that the Sun is acting up more than usual for this cycle. This means there's a higher chance of seeing auroras in the next few years, so keep your eyes peeled for colorful light displays in the sky.
Here in the U.S., and keep an eye out tonight and right into the weekend. Millions of Americans could actually see the northern lights as far south as Alabama because of this very rare solar storm.
Also, there is a particular issue scientists wish the LHC could help explain. While it did a great job finding the Higgs boson, sometimes called the God particle, but scientists are looking for another ghostly particle next, the neutrino. Neutrinos are incredibly tiny and almost have no mass, like electrons, but without an electrical charge. This makes them hard to find because they barely interact with anything around us. Even though they're everywhere, they're one of the biggest mysteries in science. To learn more about these ghost particles, a tech company, Micron, is working with CERN on a big experiment. This experiment finally gives us a clearer picture of how neutrinos behave. Scientists believe that neutrinos might be linked to the origins of our universe. Understanding how they act could answer some of the biggest questions in science. And even though the LHC won't be directly involved in this experiment, it shows how different scientific facilities work together to explain the mysteries of our world. The Future Circular Collider. Another catch is that scientists are still determining whether the LHC is the right tool for hunting neutrons. Fortunately, CERN is already cooking up an even more powerful particle collider for the future. No one knows if the LHC will find the neutrino before this new machine gets built. The Future Collider sounds impressive, so let's see what it has in store. The new collider will be much bigger and stronger than any other collider ever built. Scientists hope it will help us solve a big puzzle. What is dark matter made of? But what is dark matter in the first place? Imagine the entire universe is a giant pie. Only a tiny piece, about 5%, is the stuff we can see. Stars, planets, even you and me. The rest, or approximately 95%, is dark matter. There's a lot more out there that we can't see yet, but we know it's there. Scientists can't see dark matter directly because it's invisible. It doesn't light up or interact with light in any way. We know it's there because of the gravity it pulls on things. Scientists are still trying to understand dark matter. It might be small particles we have yet to find or even new kinds of matter. Learning more about dark matter is an essential goal for scientists at CERN, and they're hoping the giant Future Collider will help them crack the code. Fabiola Gianotti, a key executive at CERN, says the Future Collider will be an invention machine. Building this giant will require creating incredible new tech, from advanced freezers to super strong magnets and susceptible detectors. These inventions won't just help scientists, they could improve all sorts of things in our everyday lives, making a positive difference for everyone. The new collider will be built next to its champion older brother, the Large Hadron Collider. The LHC is currently the world's biggest collider, circling for 27 kilometers, but the FCC will be a different beast, even bigger and stronger. This next-generation machine will crash particles together with much more force. And there's more to the story. There's a lot of curiosity about what will happen to the LHC once the FCC is up and running. Michael Benedict, a CERN expert, explains that the LHC is a giant underground ring stretching 91 kilometers around with 8 surface spots connecting to tunnels about 200 meters deep. That's not something you just toss away. Even though the LHC is expected to finish its main tasks around 2040, there's a good chance it will stick around for smaller studies after the FCC takes center stage. CERN has yet to decide, but the council likes the idea based on the feasibility studies conducted. Eliezer Rabinovich, the CERN Council president, even said everyone wants to ensure CERN stays on top of physics and technology for the global physics community beyond 2040. Now, let us talk about the financial implications. The project is expected to cost 16 billion euros, but CERN knows this number might change. They'll have a better idea of the exact cost by 2025. So, what exactly sets these two colliders apart? The FCC will also use super strong magnets to zip particles around a giant track almost as fast as light. Then it will slam them together, and scientists will analyze the results to understand the fundamental particles that make up everything. But while the LHC can reach speeds of 13 trillion electron volts, the FCC aims to break that record by going up to 100 TeV. CERN is also planning a series of upgrades to keep the LHC running smoothly. Thank you for staying with us. Could CERN research spell doom for the word? Let's have your opinions in the comment section. If you enjoyed the video, like, share, and subscribe to our channel. Also, click the following video on your screen and you will enjoy it.